Hi there, this is Mark Alfano, and I'm here to show you how to make a particular style of network graph in Gephi where the nodes are images, in this case emoji, rather than your standard circles or dots or words. So I'm going to share my screen and just walk you through how this works. I'll post this code in the comments. So first of all, you need some data, and my data is named tweet adjacency matrix, but you can name your data whatever you want. I'm going to load it into R and split it up by community and show you what that looks like. So here we are loading our data in. You can tell it's taking some time because there's a lot of it. And I ran the head function just to show you what it looks like. So the structure here is just each row is a tweet, and then we've got a whole bunch of columns, and each column, except for the first three, represents an emoji that could be present or absent in the tweet. So for instance, we've got the raised fist, medium dark skin tone, the flag of Armenia, the warning symbol, and so on. The first three columns represent the tweet ID, the community to which the account that produced that tweet has been assigned, and the subcommunity within that main community to which the account has been assigned. You don't have to do these first three. In fact, I'm going to cut them out in just a second, but it's nice sometimes to use modularity or some other measure to divide the accounts up into different communities so that you can investigate them with a little bit more precision. So what I've done here is I've taken the data and just broken it down by the four communities that are represented in it. So community 0, 1, 2, and 3. Independently, my group has identified these as activists, left-wing politicians and media, right-wing politicians and media, and actually fans of Korean pop bands, especially BTS. So that's the first step. And then the second step, we want to throw out those columns that are unnecessary. So we're going to throw out the tweet ID, community, and subcommunity columns. And that's real quick. And then we are going to the top 50 emoji for each of the four communities, because they use different emoji to express their thinking and their emotions. So the basic idea here is we reorder the data in each of these four subsetted data sets by the sum of the columns. And because a column will have a 1 when an emoji is present and a 0 when it's absent, the sum of the column just tells you how frequent the emoji are. So for instance, I've plotted out here, just using the head function from the activist community, right? They tend to use the raised fist, medium dark skin tone, followed by the red heart, followed by the raised fist medium skin tone, followed by the raised fist dark skin tone, followed by the black heart. Right? These are the top 50 that they use. So now we've got something that we can actually work with, and then a matrix so that we can do a little matrix algebra with them. So right now they're data frames. We're going to turn them into data matrices, and then each data matrix we're going to that's the matrix itself. Each matrix we're going to transpose, which basically means flip the rows and columns. And then we're going to multiply each transpose by its original matrix. And that will give us a nice adjacency matrix that we can then load into Gephi. So let me just select that. And we go back to R. And this just gives you a look at what this produces. So what we've got here is a symmetric matrix where the rows and the columns are identical. And the diagonal tells you about occurrence. So raised fist, medium dark skin tone, that occurs in 4,328 tweets. The red heart, that occurs in 3,246 tweets. The raised fist medium skin tone occurs in 2,639 tweets, and so on. And then we also have co-occurrence. So the raised fist medium dark skin tone co-occurs with the red heart 296 times. It co-occurs with the raised fist medium skin tone 1,532 times. It co-occurs with the raised fist dark skin tone 1,568 times, and so on. And I've just outputted all of these into my R folder as CSV files, which can then be loaded into Gephi. So let me show you what that looks like. This is the finished product. But if you want to open one of these, initially, this is what it's going to look like. So that's what I output it as. It's going to ask you, are you sure you want to add this as a comma-separated matrix? And the answer is yes. So I say yes. There's no time intervals. I don't care. It's an undirected network because this is co-occurrence. Right. And so then if you look at this, initially you're going to want to filter out self edges because those are meaningless, self loops. Take those out. Now, the problem is that Gephi is going to just render your nodes as the name of the emoji, and that's not what you want, right? What you want is those pretty pictures. So in order to get what you actually want, you need to install a plugin. Go to this plugin here. And the one that you want in particular, there's a bunch that are cool, but the one that you want is image preview. So if you just search for image preview, you can install it. And this will only render your images in the preview screen. It won't render them in the overview, so don't worry about that. But if you install this, you should be good to go. What you'll then need to do is go to the data lab here, and you're going to have to add a column. So that's done just by clicking add column. And here's what it looks like in one that I've already gone through. I also calculated the weighted degree in the modularity class, but you'd add a column and title it image. And then for each of the emoji or whatever other images you're interested in displaying, you need to give the file name for that image. And in order for Gephi to be able to find it, you need to go to the preview, go to settings, right? So not manage render, or not manage renderers, but settings, scroll all the way down, and there will be this thing that says node images. That won't appear unless you have the plugin installed. If you say yes, render nodes as images, then it'll ask you to specify a path to your images. In my case, it's in my R folder. And what that looks like on the actual desktop is, right, so here's my R folder. I've just got within that a folder named emoji. And I went and downloaded a whole bunch of emoji, the ones that correspond to all of the things that I'm plotting. There are hundreds of these, so I didn't download all of them. You can do as you please. I also didn't rename them, but you can basically just grab everything that you want. Actually, this is the one I'm using. Everything that's actually in your data set, put it in here, and then just copy the file name and throw it into this image column in the data lab, and that will show you, that will get you what you want. So then you go over to the preview, and you want to manage your renderers to ensure that image nodes is the top one. You can do it however you want, but that I find is the most valuable. And at least in my case, the way I tend to work with these is, right, so I cut out the self loops. I usually calculate statistics for average weighted degree because that's meaningful. That just means how many other emojis appear in the same tweet as this one. And modularity, which is meaningful because that divides emoji into clusters that tend to co-occur. And then I'll go over to appearance, size them by ranking their weighted degree, and color the edges between them by partitioning based on their modularity class. For layout, I tend to use force atlas followed by no overlap. You can do as you please. And then once you've done all that, you're in a good position to actually plot this thing out. And you get, I think, quite an informative graph that shows you what sorts of emoji are being used by a particular community when talking about a particular topic. So for instance, this is the right-wing sort of MAGA community talking about the Black Lives Matter movement. And you can see that they don't actually talk about Black people at all. They talk about the United States, about loving cops, about Christianity, and so on. Whereas if we look at, for instance, the activist community, right, they've got the raised fists. The self loops are not taken out here for some reason. They've got the raised fists. They've got a kind of rainbow of hearts. They're talking to you. They've got, this is George Floyd, I assume. The black dot, I assume, is representing the Black Lives Matter movement. Likewise, with the Democrats, you see a lot of similar things with the rainbow of hearts and the fists, but they have more political concerns as well. So there's the blue wave election. For them, the blue heart is vote Democrat, whereas for the MAGA crew, the blue heart is we love the cops. They've got Lady Liberty here. And you can see in the K-pop group, right, they've got the purple heart, which is specifically a reference to the band BTS. In this data set, it also seems that there are a few Black folks who are responding like, why are the Korean pop fans even interested? I'm confused, which fair enough. But yeah, you get these nice images which can help to tell a story. And I think, given that people express themselves in this way nowadays, it's valuable to be able to study and represent the ways that they express themselves. So this combination of R and Gephi is one way in which we can do that. I hope this has been helpful. I'm going to post this online in just a minute. And thanks for your attention.